Hi, good day. So I am here to share you about my topic, which is skewness in relation to central tendency. Skewness is a measurement of the distortion of symmetrical distribution. So if the bell curve shifted to the left or right, it means the data set is skewed. It also tells us the direction of outliers, and due to skewness, we must know the right measure of central tendency to use to determine the outliers. Then skewed distribution have two types, which is left and right skewness. As I mentioned earlier, the positively skewed or right skewed show the tail is on the right side of the distribution is longer than the left side. Apparently, in this case, the mean is greater than the median, and the median is greater than the mode. So to elaborate more, I will show you an example. The data set consists of 50, 51, 52, 59. So the first thing to do is to get the mean. You add the sum of all values in the data set and divide it into the total number of terms in the data set. So the mean is 52.4. Next is to get the median. Don't forget, there is two ways to get the median, and it depends if the value is an odd numbers or even. As we look back, we get the location by adding 5 and 1 and divided by 2, so the location is on third value, which is 51. And while mode is the repetitive value, then the mode is 50. To conclude, the mean is greater than median, and median is greater than the mode. Hence, the data is more bent towards lower side, where the average will greater than middle value and the mode. On the negatively skewed, it is opposite to the positive skewed. As you can see definition, the tail is longer on the left side, and aside from that, the mode is greater than the median, and median is greater than the mean. Also, don't forget that the longer tail is the outliers. Here is an example. It states the income of every number of people, and the graph projects us the huge gap in the income distribution, and the tail is bent toward left side area. Afterwards, we can see how we calculate the mean. We add the sum of all the values of the data set and divide it by the total numbers of the terms. Then, on the median, we locate it first, then find the value, which is 80,000. The mode is the highest value, which is 35,000. Next is the structure of the two types of skewed distribution. As you can see, it represents the left and the right skewed distribution and the difference of each other. The capabilities of mean, median, and mode. It states that the mean is good measure when the value is closer, and median accurately describe the outliers. Then the mode is good measure to use when it is categorical data. Why median is more accurate on the outliers than mean? The main reason is the median pertains only the rankings, while the mean include outliers when adding all the values of the data set. Skewness and outliers. Skewness tells us the direction of the outliers by using the median, and the outlier is a low data point and high data point, which means that the outliers can affect the symmetrical distribution on having low values and high values, as long as it has a huge gap on other values. So take a glimpse on the effect of outliers provided. The mean increase with high outlier and decrease with low outlier. The median little change, the mode have no change, and the range, the spread of data increase. Don't get confused which measure of central tendency to be used in skewed data and determining the outliers, since the most common use are median than the mode. To provide example without outlier and without a mode, we calculate the mean, median. On mean, we add the sum of all values and divide it by the total number of terms in the data set and get the value of 90.25. On median, the middle value is in between 89 and 90, so we add them and divide it by the number of terms and get a value of 89.5. Then on the next example with outliers and without mode, we get the mean by adding all the values of data set and divided by the total numbers of terms. Then the value is 83.2. Then after that, we get the median which is 89. On this table, it is comparison without outlier, and with outlier, the outlier decreased the mean of 90.25 by 7.05, which turned into 83.2. Then next is the outlier decreased the median a little by 0.5, which becomes 89. Now, using median and interquartile to find out outliers. Since I already said that the median is the most accurate in terms of determining the outliers. In this example, we have the value of 1, 2, 5, 6, 7, 9, 12, 15, 18, 19, 38. On the first step, find the interquartile. Next, find the median, but first and foremost, put them inside of parentheses. Step 1.2. Find the Q1 and Q3. Q1 can be the median in the lower half, and Q3 will be the median of the higher half. Step 1.3. Subtract Q1 from Q3, then we got 13. Step 2. Calculate 1.5 times interquartile equals 1.5 times 13 equals 19.5. Step 3. Subtract Q1 to lower fence. 5 minus 19.5 equals negative 14.5. Step 4. Add to Q3 to upper fence. 18 plus 19.5 equals 37.5. Step 5. Add the fences to the data. Then if the value is outside of the fence, that value must be the outliers. So 38 is the outliers. Skewed distribution and real-life situation usage. Number 1. Cricket score. When teams scored above 60 and only few of them record a low score. Number 2. Exam results. Increase of difficulty, the students have low scored and few have high scored. This is an example of positive skew. Number 3. Average income distribution. Number 4. Human life cycle. 5. Taxation regimes. Number 6. Distribution of stock market. By the help of the negative skewed distribution, it has slightly returns on the most day and negative returns occasionally. Number 7. Real estate prices. Number 8. Retirement ages. Number 9. Movie ticket sales. When the movies released are not good in market, then only few of them are blockbuster. An example of positive skew. Number 10. Record of long jumps and at a competition. Conclusion. Through my discussion, it pertains the main point of my topic that the skewness affect the measurements of central tendency, which make it into relations to one another. By knowing about two types of skewness, determining outliers and comparison of data with outliers and without outliers is a vital knowledge on statistics that applicable in each sector of community like stock market returns. The median is the mostly used in the case of having outliers than mean and mode, since it is less susceptible to outliers, and using median and interquartile range, we can determine outliers. Lastly, as the distribution having outliers, the mean, median, and mode will change its values and position on the chart.